In this example, there are two cars, and they're riding on roads that meet at a 60-degree angle. So our picture, here's road 1 and road 2, and this angle must be 60 degrees. We're told that car A is 3 miles from the intersection. So the intersection's here, there's car A. We're told that car B is 2 miles from the intersection. They're both traveling away from the intersection in question A. So they're both going in this direction and that direction. And we're told their speeds. So we're told that car A, or dA dt, is 40 miles per hour. And that car B, dB dt, is 50 miles an hour. And the question is, how fast are the two cars separating? So the length that shows the separation of the two cars is this length right here. Now all we know is the angle, this angle down here is 60 degrees. We don't know anything else about this triangle, so we cannot assume that it's right, and I would suspect it's probably not right. So I'm just going to call this length that we're looking for C. And we're going to need to recall some things, at least for this first question, about the law of cosines. C squared is equal to A squared plus B squared minus 2AB times the cosine of the angle opposite. Right? So theta is 60 degrees in this case. And what we want to know is how far the cars are separating. So what we want to know is dc dt. Well, if I take the derivative of this, I'll get 2c dc dt. And that'll be equal to 2a dA dt plus 2b dB dt. Now we've got some power rule stuff to use. Since theta is 60 degrees, one of the things that I should recognize is that the cosine of 60 is 1/2, and so that this portion of our formula, since the cosine of 60 is 1/2, will just be minus AB. So when I use the product rule on that, what I'll find is I'll have minus dA dt times B plus negative A times dB dt. This is not a very pretty formula, but it is the best relationship we have in this case. And when we solve for dc dt, what we find is that dc dt, dividing both sides by 2c, I'm just going to leave it this way, rather than make it a big deal. 2a dA dt plus 2b dB dt minus dA dt times b minus a times dB dt all over 2c. Well, to answer this question, I know what A and B are, but what I need to figure out is what is C. So using the law of cosines, I know that C squared will be equal to A squared, which would be 9, plus B squared, which would be 4, minus 2 times 2 times 3. So 2 times A would be 6, times 2 would be 12, so minus 12, times the cosine of theta, which is 60 degrees. And cosine of 60 degrees is 1/2, so this is 9 plus 4 minus 6, which is 7. No, yeah, 13 minus 6 is 7. So c squared equals the square root of 7. Now I've got everything I need to solve for dc dt. dc dt is equal to 2. Get a little big here. 2 times a, which in this case is 3, times dA dt, which is 40, plus 2 times b, which is 2, times dB dt, which is 50, minus dA dt, which is 40, times b, which is 2, minus a, which is 3, times dB dt, which is 50, and all of that is being divided by 2 times the square root of 7, which is the length of c. And simplifying this, we will end up with 39.686, and that will be miles per hour. Now in the second part of the question, the situation is a little different. Car A is traveling away from the intersection and car B is traveling towards it. So we'll have to redraw our picture. So it's the same intersection. So two roads meeting at a 60-degree angle. But car A is traveling away from the intersection. So it's here, it's past the intersection, it's 3 miles away, going in that direction. But car B hasn't gotten to the intersection yet, it's traveling towards it. So it could be here somewhere, 2 miles from the intersection, and it's going in this direction. And again, the question is, how fast are the two cars separating? So this time, what we're looking at, in a sense, is this length. What's going on now? Notice the angle that relates everything is different. Right? If this is 60, then the angle we're looking at is 120 degrees, because they would be supplementary. So it changes some things for us. We know from previous work we're going to need to know the length of c. And so to solve for c, we'd have to use the law of cosines, which again would be a squared. So in this case that would be 3 squared, plus b squared, which would be 4. This just changes to 9 now. Minus 2 times 3, which would be 6, times 2 would be 12, times the cosine of 120 degrees this time. And the cosine of 120 degrees, since its reference angle is 60, would be negative 1/2. So c squared would be 13 plus 6, or c would be the square root of 19. So now we've got the information needed to figure out dc dt. So using the work we've already done, we know that dc dt is equal to 2 times a, which in this case is 3, times dA dt, which is 40, plus 2 times b, which in this case is 2, times dB dt, which in this case is 50, minus dA dt is 40 times b, which is 2 minus 3 times 50, and all of this will be over 2 times c, or 2 times the square root of 19. And when we simplify it this time, we will find that is 24.089 miles per hour. So at this point in time, the distance between the cars is getting closer to one another.